Problem 21. Some identical glasses are stacked on top of each other. A stack of 8 glasses is 42 centimeter high and a stack of 2 glasses is 18 centimeter high. How high is a stack of 6 glasses? These are our option and these are the stack of the glasses. So if you understand the question, we know that the glasses when stacked overlaps. So only the first glass is of full height. The second glass is of some height. So here is what we know. A stack of 8 glasses is 42 centimeter. 42 centimeter. Stack of 2 glasses is 18 centimeter tall. So can we find the height of these glasses? So there are 1, 2, 3, 4, 5, 6 glasses of same size. So the height of 6 glasses is 42 minus 18, which gives us 24 centimeter. Now since we know the height of 6 glasses of same height, we can determine the height of one glass, which is 24 divided by 6 gives us 4 centimeter. The height of smaller portion is 4 centimeter. We can determine the height of the full glass, that is 18 minus 4 gives us 14 centimeter. Now we know first glass, that is 14 centimeter. That is first. Now we have to determine the height of the 5 glasses. So we have plus 5 into 4 centimeter gives us, this gives us 20. So 20 plus 14 gives us 34 centimeter. So our answer is option D, 34 centimeter. Problem 22. In the picture below, each animal represents a positive integer and different animals represents different integers. The sum of the two integers in each column is written below. This is what they are referring to. What is the largest possible sum of the 4 integers in the first row? So we have to determine the largest possible sum of the 4 integers in the first row. These are our options. Now let's start with the smallest column total, which is 3. So let's say hen is 1 and tiger is 2. So it becomes 1 plus 2 gives us 3. The problem says the top rows should have the largest possible total. So we want to use the higher number there. Now the next smallest column total is 7. We write turtle as 3 and dog as 4. 3 is the next available integer. So 4 plus 3 gives us 7. Next is the second column, which is the total of 11. We assign camel 5 and rabbit 6. That becomes 6 plus 5 and gives 11. The last column left has a total of 15. So we assign the next available positive integer, that is horse we give 7 and cow we give 8 and 7 plus 8 gives us 15. Now let's add up the values in the top row, which includes cow plus rabbit plus tiger plus dog, that gives us 20. So our answer is option C, 20. Problem 23. To unlock a given lock, you get the following 4 hints. These are our 4 hints. What is the code for the lock? These are our options. Now let's look at the clues step by step. Start with the last clue. All of these digits are incorrect. It says that 7, 3, 8 are incorrect. So any digit in the code that contains 7, 3, 8 should be removed. So looking at these clues, the first clue has 8, so we remove it. We do not see 7 or 3, so we can ignore those. Any options that contains 7, 3, 8 should be removed. So option B should be removed. Now the first clue says, one of these digits is correct and in the right place. So there are two digits left, 6 and 2. Either 6 or 2 are the correct digit and is at the right place. So assume that 6 is at the correct place. Then option A and C could be our answer. Let's look at the clue 2. It says one of these digits is correct but in the wrong place. So if 6 is correct, that means it is at the wrong place. So this conflicts the first clue. So that means 6 is not at the first place. So we remove 6. This means option A and option C are not our answer. Now we go back to clue first. Since 6 is incorrect, that means 2 is the correct digit and is in the right place. So only option D reveals that. So 2 is at the right position. Now let's verify if D is our option or not. So the clue 2 says, one of this digit is correct but in the wrong place. That means we have 1 or 4. That means one of the digit. If 4 is the correct digit, then it should be at this position. So that implies this. Now clue 3. 2 of these digits are correct but in the wrong place. So 6 is out of our picture. So 2 of these digits are correct. That means 2, if 2 should be at this position and at 0 to be at this position, that gives us option D. So our answer is option D, 0, 4, 2. Problem 24. Anna has the shape shown on the right. Which of the following shapes is the same as Anna's? So this is Anna's shape. We have to compare with these options and find it out which one matches with this one. So let us observe this shape. So we can see that this is attached at the center and this is also attached at the center. So if any of the shape does not follow this, is not our answer. So we see that it attached at the end. So A is not our answer. It again attached at end. B is not our answer. C could be our answer and D could be our answer because it's at the center and this is attached at here at the end, not our answer. Now we have to find whether C or D is our answer or not. Now let's see. This shape is adjacent to this shape. So we see that option C has that. Option D has opposite to it. So this could not be our answer. Option C is our answer. Problem 25. 4 villages A, B, C and D lie along a road in that order. The distance between neighboring villages is 10 km. There are 10 students who live in village A, 20 students who live in village B, 30 students who live in village C and 40 students who live in village D. The villagers want to build a school so that the total distance traveled by the students when going to school is as short as possible. Where should they build the school? These are our options. This is a question we will solve using median and cumulative count. Let us solve it now. So we know from the problem, village A has 10 students, village B has 20 students, village C has 30 students, and village D has 40 students. Now let's imagine lining up all the students from village A to D and putting a number sticker on each student's back in sequence. This will be our cumulative count. So we start from village A. We start putting sticker 1 student to 10 students. Now when we come in village B, we will start putting the sticker from 11 and then we mark 20 students till 30. Now in village C, we will start from 31 and then we'll put the sticker on 30 students The last student will be 60. Village D, we will start from 61. Put stickers on 40 students. So the last student will be 100. So we have 100 students in total. So this is our cumulative count. Now we will use median. The median is the middle value in a data set when the values are arranged in ascending order. So 100 divided by 2 gives us 50. So the 50th student will be in between this range, which is in village C. Therefore, the best place to build the school is in village C, which is option C. Problem 26. Elena wants to place 5 distinct single-digit numbers in the 5 circles so that the number inside each triangle is the product of the 3 numbers on its vertices. What is the sum of the 3 numbers on the vertices of the shaded triangle? So we have to determine the numbers on this vertices for this product. Let us name this circle so that it would be easy for us when we are referring to them. We name them A, B, C, D, E, and E is the common one. To solve this, we will start by considering the factors of the given product. So we will take first number, 105. So we divide by 5, we get 21. 7 multiple of 3 gives us 21. And 7 times 1 gives us 7. Let us find the factor for the second number. So the second number is 84. We divide by 2. We get 42. We again divide by 2 gives 21. And then 3 7 times. And 7 times 1. Let us go on for the third product is 168. So we divide by 2 gives 84. We divided by 2, we get 42. We again divide by 2 gives 21 and 3 times 7 gives 21 and 7 times 1 gives us 7. Factors for last number. So we have 110. We divide by 2, we get 105. We divide by 5, we get 21. We divide by 7, 3 times and 3, 1. So by looking at the factors, we can see that 7 is common in all the products. So what does it mean? That the 7 is at the center of this picture. So our E is 7. Now let us look at the other circles. So 105 has 7 already taken and left is 5 and 3. What does it mean? It means that A is 5 or 3, B is 5 or 3. Let's move on to the next factor. 84. 7 has been already taken and we see 3. So that means the common between 105 and 84 is B. So if 3 is in here, that means 3 is common between them. So B is 3. Now question says that we need to have the product of the 3 numbers. So we see the factors. So we multiply 2 by 2 and get a factor 4. So what does it mean? It means that C equals to 4. Now let us move on to our next factor, 168. So we already have taken 7. Now 168 lies between E, D, C. That means any factor that is common to 84 should be there. So C, there should be a 4 in there. So 168, we can have 4. We can make, yes. When we make 4, the next number remaining is 2 by 3 gives us 6. So what does it mean? It means that D is 6. Now let us consider last number 210. So we have 7 taken and 210 would be common with A, and we know A is 5. So we write 5 here. Which numbers left? We have 2 and 3. That means we multiply 2 by 3 gives us 6. So this proves that D is 6 as well. Now question demands for the sum of the 3 numbers on the vertices of the shaded triangle. So we have E, that is 7. We have C, which is 4. And we have D, which is 6. So it equals to 17. So our answer should be option D, 17. Problem 27. Which of the following nets cannot be folded into the solid picture? So the question says cannot be folded. So let's see if which one can be folded. So we looked into this. We have 2 horizontal dash and there are 2 vertical ones. So we fold this and this will come on top and this will make, so this would come like this would on the side. So this is possible. So this is not our answer. Option B. So we have plus in cording and we cannot make it because when it turns back, it would turn back differently and we need a horizontal line. So this could be our answer with, so that means we cannot fold it into the similar solid. Let's try option C. So we have 2 verticals, 2 horizontal, that comes on the side. Yes, this is possible. This is not our answer. We have 2 horizontal, vertical comes on top because it moves like this. It comes on here and that forms this solid. So this is not our answer. So we have 2 horizontal lines in here, plus sign, and when it comes on, it marks as this. And this is possible. So this is also not our answer. So our answer is option B, is the net which cannot be folded into this solid. Problem 28. Joining small cubes of the same volume but of different material forms a rectangular box as shown in the figure. If each white cube weighs 2 grams and each gray cubes weigh 1 gram, how many grams does the box in the figure weigh? And this is the figure we are talking about. These are our options. To solve this, let's consider the cube and idea of dividing it into 5 equal bands. So this is the band I am referring to. So this is 1 band, this is 2 bands, this is 3 band, this is 4 band, and this is 5 band. So these are the 5 bands we have. So we have to determine the number of cubes in 1 band, then we can determine in rest of the 4 bands. So let us solve this problem. So first calculate the number of cubes in the outer band. So we know the length is 5, 1, 2, 3, 4, 5, and width is 6, 1, 2, 3, 4, 5, 6. So the number of cubes in the outer band is 5 multiplied by 6 length into width gives us 30 cubes. Now calculate the total number of cubes. So we have how many bands? We have 5 bands. So each band contains 30 cubes. So 5 bands contain 30 multiplied by 5 gives 150 cubes. Now we will divide the cubes by color. We know that the number of white and gray cubes are equal. This means the number of white cubes is half of the total number of cubes. So white cubes is equal to 150 divided by 2 gives us 75 cubes. Similarly, gray cubes is equal to 75 cubes. But from question we know that the white cube weighs 2 grams. So now calculate the weight of the white cubes. The weight of the white cube will be 75 into 2 gives us 150 grams. Gray cubes, question says, is 1 gram. So we multiply by 1 and we get 75 grams. Now calculate the total weight. The total weight of white and gray cubes is 150 plus 75 gives us 225 grams. So our answer is 225. Problem 29. The three pictures show a structure made from identical cubes as seen from the top, from the front, from the right. What is the maximum number of cubes that could have been used to build the structure? These are our options. So by observing the picture, we can see that the entire shape is a cuboid with dimensions 4 units long and 3 units wide. The cuboid will look like this. So we see that this is 4 and the front shows that's 3. So this is the cuboid it will look like. Now we will look at the structure layer by layer from top to understand how it's built. So we'll make a top layer grid with all these cubes marked in it, and then we will bring up the front and then we will analyze. So there are 3 layers: top, middle and bottom. So we will go from top to bottom, marking where cubes are placed using the front and right view. So now let's create space for the 3 layers and start marking them. So we'll bring the first top layer. The top layer has grid 4 by 4 and has the cubes marked as the top layer. So we'll create the space for the middle layer and we'll mark the grid. Similarly, bottom layer will mark the grid like this. Now let us focus on the front part of the structure. So we'll bring the grid and fill in with the top layer, which shows like this. So we have 2 cubes and we will mark it in the center. We bring the grid for middle layer. We mark the cube as this one. So we have 2 in here. Now we'll bring the grid for the bottom layer and we have 4 cubes. So we'll mark as 4. Let us bring the right structure. So we have 2 cubes in here. We mark it. For middle structure, we have 3. So we mark 3. For bottom, we have 4. So we mark all 4 grid. Now let's analyze the front structure. So here we have no cubes. So we remove this one. We have a cube in front. So we keep this. There is nothing in front of it. So we remove it. Let's analyze the middle layer for front wall. So there is nothing. We remove it. There are cubes in front, so we keep it. There are cubes in front, so we keep. There is nothing in front of it, so we remove it. Bottom layer, there is 1 on each of these grids. Now let's analyze right side. So the top layer on the right has 2 cubes. So we mark it and there is nothing, so we remove them. There is nothing in front, we remove them. Now let us consider the middle layer. The middle layer has 3 cubes. There is nothing, we remove it. Bottom layer on the right is completely filled with 4 cubes. So we keep it. So let us count. We have 1, 2, 3 and 4. So we have 4 in here. We see that there are 6 in here. And in the bottom layer, we have 9 in here. Now we sum them and we get 6 plus 4, 10. 10 plus 9 gives us 19. So our answer is option B, 19. Problem 30. 30 people are sitting around a circular table. Some of them are wearing hats. Those who do wear a hat always tell the truth, while those who do not wear a hat can either lie or tell the truth. Each person says, at least one of my two neighbors is not wearing a hat. What is the greatest number of people who could be wearing a hat? These are our options. Now let us consider a circular table and assume that there are 30 people sitting on it. Now we will use H to represent a person wearing a hat who always tells the truth, and NH for a person not wearing a hat who may tell the truth or lie. Let's assume the person sitting on chair 1 is wearing a hat here. It's wearing a hat, we mark it as H. Now according to the rule, at least one of their neighbors must not be wearing a hat. So the person on chair 2 must not be wearing a hat. So we marked as NH. A neighbor of chair 1 could be H. Now to maximize the number of people wearing hats, we try to place hat wearers wherever possible while still following the rule. Let's continue. One neighbor of H should not be wearing a hat. So the person on chair 29 should be NH. Chair 3 can be H because chair 2 is NH. Chair 4 can also be H since chair 3 is H, but still has chair 5 to fulfill the rule. So the chair 5 must be NH. So if you observe, we see a pattern. A group of 3, it is NH, H, H. So this pattern repeats every 3 chairs and contains 2 people. So if you will consider the entire circle of the chair, it will look like this. And we see that this pattern continues. So now one solution for it is that you count number of H and you will get an answer. Or you can make a group of these patterns and see how many are there. So let's mark 1 group, 2 group, 3, 4, 5, 6, 7, 8, 9, 10. So we have a set of 10 full groups. So each group contains 2 hat wearers. So the total number of people wearing hat is 10 multiplied by 2 gives us 20. So therefore the maximum number of people who could be wearing hat is 20, which is option D, 20. With that, we wrap up the Canadian Math Kangaroo 2022 for grade 5 and 6. I hope you had fun solving these puzzles and learned a few cool strategies along the way. Don't forget to subscribe and hit that bell so you don't miss more brain-boosting math adventures with me. Until next time, keep solving and keep smiling. Bye for now.